given. I'm given the function, some values, right? I'm given the derivative and the double derivative. And so when we have all this information at the same time, sometimes it's a little overwhelming, okay? So we're just going to make sure we remind ourselves what we're going to be answering. We cannot at this point do letter C. And really, we'll talk about G. I wouldn't expect you at this point to really for sure know how to do D, but it'll make sense too. But we should be able to do A and B. So let the function, let f be a function that's continuous on the interval 0 to 4. The function f is twice differentiable except at x equals 2. So it tells you here that at x equals 2, the derivative doesn't exist, therefore the double derivative doesn't exist. The function f and its derivatives have the properties indicated in the table above, where d and e indicates that the derivative of f does not exist at x equals 2. So let's look at A. For 0 to 4, find all values of x at which f has a relative extremum. Justify your answers. What do you want to look at for that?
First derivative.
Okay. The first derivative. So we're gonna, and what are we looking for? Good. I'm glad that you said that it switches, not just where it's a 0. We gotta check if it switches, right? All right. So from 0 to 1, this is the first derivative. The first derivative is positive, then it's 0, and then it's positive. Has a relative extrema occurred? No. Okay. A leveling off of the slope has occurred. Okay. Then it is not differentiable. We don't know what that means. Well, we do a little bit know what it means because is the function defined there? So what are the ways then that the derivative wouldn't exist? Cos, corner, but since since it exists there, it's not an asymptote, I guess is what I'm saying. Okay. Ooh, then it's negative. Okay. And then it continues to be negative. There's no 0 or undefined there. So let's see. We said then there's only one extrema, huh? Where was it? At x equals 2, the derivative switches from positive to negative. So this is a what? Max. Okay. So at x equals 2, f of x has a relative maximum because f prime of x switches from positive to negative. Okay. Now, even though I don't ask about inflection point, we're going to sketch a picture of the graph, and so we should address concavity. So we should try to look at the double derivative and see where the concavity switches. And I even sometimes like to write some things out. Okay, so we know that at x equals 2 there's a relative max. We know that the slope is 0 here, so that's going to be a key point, and the slope is, so it's going to be some kind of, we said maybe cusp corner or something there. Let's go to the double derivative. The double derivative is negative and then switches to positive. What does that mean? concave down. Yeah, this is concave down on this interval, and then switches to concave up, and then switches to concave down, concave up. Lots there, right? Are we told what f of 0, f of 1, f of 2, f of 4 is? Are. Alright, I'm going to transfer this. You can do it right on that graph if you want, but here we go. Sketching graphs is tough. First of all, let's start with this. What is f of 0? In the table, f of 0 is negative 1. So I'm going to start this off at negative 1. What is f of 1? 0. What is f of 2? 2. So I'm going to just plot these points and then I'm going to address my other stuff in a second. What is f of 3? And what about f of 4? Don't know. Okay. Now, from 0 to 1, I'm going to make this concave down, and then concave up from 1 to 2. Also, I'm going to make the slope 0. So this is what I'm going to do when it crosses. I'm going to go like something like this. Now it switches instead of concave down to concave up. How did I know that it was still, the function was still increasing? Because remember how we looked here and we said the slope levels off, that's that 0. It's also f of 1 is also 0. So it goes through this point and there's a slope briefly of 0. Okay. Now, remember what happened at f of 2? We're going to make this like a cuspy thing, and then we're going to make it concave down. So I'm going to make, instead of this is concave up, right? Now I'm going to switch it to more concave down, so it's like I want it to kind of curve like this. And then what else? Anything else? I don't think so. Because then it's concave down the rest of the time, right? Or does it switch? So I have to do this. Kind of start to make it switch again, right? Okay. So make sure that it's clear. I hope that that's clear that that's a cusp. Okay. So we got concave down, concave up, concave down, concave up. And I plotted my points to begin with. Did I make sure that x equals 2 there was a relative maximum? Yep. Just like I stated before. Tricky, tricky. We're going to continue to work on curve sketching an entire year. So that is something that's not like, oh, we're going to do it today and we're done with it.